Okay, in this situation, we're given two sides of a triangle. I can see that right away. There are my two sides, and I'm given an angle. And the next thing I notice is that I even have a matching pair. I have angle A and side A. So that means when you have a matching pair, we're using law of sines. So right away, I know this is not a law of cosines problem, it's a law of sines. And the next question is, what type of law of sines am I dealing with? Is it one of the nice ones or one of the not as nice ones? So I'm looking at this angle, and that's acute. So that means I may have an ambiguous case, or I may not. Remember, if that angle were obtuse, then I know there's only one solution possible. But when it's acute, there might be a couple things going on. For one thing, we always have to keep in mind this. You might have no triangle possible, and you'll know it real quick if you see that. You'll start getting domain errors in your calculator. Things will not work at all. But more worrisome than no triangle possible is the idea that I might have two triangles possible, because that means you have to fill in all this stuff with a whole, it's like doing two math problems at once. So let's take a look. And the test, remember, the test is the matching side. So if the matching side is long, that's going to give us a different scenario versus if it's short. Okay, if the matching side is long, remember that tells us there is only one triangle possible. Whereas if it's short, that tells us there are two triangles possible. That's called the ambiguous case. Ambiguous meaning we're not sure which one of these triangles it is. So take a look at your matching side. That's side A right there. It's shorter than C. So bad news, guys. We're heading for a longer video. We're going to have to solve two possible triangles. We start it the same way as usual. We just say, well, what's the first thing I can find here? And since I have a pair of A's and I'm given a C, that means I need big angle C. So we just get started there. Put the sign on top. That'll make it a little easier. Say sine of C over C equals sine of A over A. And oh, you know what? Actually, before we even really get going in this, I want to fill in some things. This will make this a little easier. I know the angle is 50.01, and now I know I need that bottom section too, because there's two triangles. I know side A is 8.3, so I put that in both places, and I know side C is 9.73. Okay, 9.73. This isn't going to help you in points so much, because those aren't worth much since they're given to you, but at least it'll help organize your thoughts, know what you need to go for. So I'm going to solve this guy now, angle C. And we're going to set it up this way. I'm going to say sine of C equals the side C times sine of angle A divided by side A, which, using those givens, is 9.73 times the sine of 50.01 degrees, all divided by, looks like 8.3. So I push that into my calculator, and what do we get for angle C? We get this. We're going to do some inverse sine. So we've gone over the inverse sine stuff. Let's just skip right to the angle. That is going to be 63.92 degrees. Okay, great. So we've got our angle C, 63.92. Now here's how you handle the ambiguous case. Because inverse sine on a calculator will always give you an acute angle, now you need to think and get one step ahead of the calculator and say, okay, how do I find the obtuse angle? I know there's an obtuse angle for C. How do I find what that is? And what you do here is you should simply say, well, the obtuse angle C is equal to 180 minus 63.92. Okay, so breaking out my calculator here, that's going to be 116.08 degrees. Okay. 116.08 degrees. And now what's left is to find angle B, which should be pretty quick because, let me change colors here. If I'm looking for angle B, I have this. I know that, the three angles added together is 180, so this should be pretty quick. I can say B equals 180 minus A minus C, and that's going to give you different results in the top and in the bottom. So in the top, in the first case where C is acute, I get this, 66.07 degrees. In the bottom, where angle C is obtuse, right? There's much less angle left to work with here. I only have 13.91 degrees to fill out that 180. And now you go find side B using the law of sines again. Okay, so I'm going to stop here. This is getting long enough. The procedure is really not, there's nothing new going on here once you get past this step. This is the really important thing. That sets up your second triangle, but you solve it the same way using the law of sines.